Quantization is the situation where physical quantities like position, energy, and momentum can only have certain discrete values. For a particle in free space, these physical quantities are continuous. But for a particle bound to an area of space, they can only have certain discrete values. The energy contained in a given frequency of electromagnetic waves is also quantized. That is, it always has the same value at the same frequency. The energy is found in discrete packets called photons. The quantization of electron energy within an atom explains much of their behavior, such as why atoms emit only discrete frequencies of light. This illustration shows an electron sitting in a low orbit within an atom. A photon comes along, which is absorbed by the electron jumping into a higher orbit. The electron then emits a photon of the same frequency, jumping back to the lower orbit. There are several natural units that were proposed by Max Planck. They are based on 5 universal physical constants: the gravitational constant, Planck's constant, the speed of light in a vacuum, the Coulomb constant, and Boltzmann's constant. Most of these natural units have no physical significance. However, 2 of them, Planck Length and Planck time, are the smallest possible measurements of space-time, according to our current understanding of the laws of physics, specifically the uncertainty principle when applied to these scales, suggesting that space and time themselves may be quantized. The formula for Planck length shown here is the square root of Planck's constant times the gravitational constant divided by 2 pi and the speed of light cubed. Its value is 1.616252 times 10 to the negative 35 meters. This is the smallest measurement of length that has any meaning within the laws of physics as we understand them today. Here is the formula for Planck time. Planck time equals the square root of Planck's constant times the gravitational constant divided by 2 pi and the speed of light to the 5th power. Its value is 5.39124 times 10 to the negative 44 seconds. This is the amount of time that it takes a photon to cross a Planck length. It is the smallest measurement of time that has any meaning within the laws of physics as we understand them today. In conclusion, quantization requires physical quantities to have discrete values. It explains much of what goes on inside the atom. Finally, our current understanding of the laws of physics suggests that space and time are also quantized.